Okay, so where should we be kind of calculus-wise? If you click on week 3, you'll notice I still have to do a lot of grading, by the way. I got 38 assignments that have to be graded from the last parts of last week. This past weekend was really crazy. I am going to try to get all that up to date as of now. I know you had a quiz last week. I'm going to grade that tonight so you guys can have that feedback just to know how it went. And I will get that graded tonight at some point, and then you'll be able to see that tomorrow. But what do we have for this week? I want to make sure everybody sees. So we're going to do some in-class work today on slope fields and just kind of overall review for the Unit 7 test. There is an optional but highly recommended Unit 7 review worksheet. You can click on here and you'll get that worksheet. I just actually want to make sure the link works. Yeah, so it should upload. I don't know why it's not. That's interesting. You might have to download it instead of just opening it. I think if you download it, it opens up in a better version. Um, so when is the test? That's the next question. So what are we going to do today? Our homework is because some of you might be taking the ACT tomorrow at Tartan. Here's what we're going to do for this week. We're going to review today in class. You have the optional review assignment worksheet, but I would definitely do that. I will post these answers in Schoology shortly. And then the homework tonight is to work on any missing work. Your last chance to turn that homework in is this Sunday at basically midnight. On Wednesday, we're going to do an in-class review day. And I might even answer some questions from this optional review if you had them. We could answer those in class, but I'm just going to kind of talk about what's going to be on the test, what should we review for. And then the actual test itself is going to be available to take Wednesday in the afternoon if you would like. However, some of you will be in Tartan that day, and since you get like I think it's 90 minutes for this test. That's not enough time to take it in class at Tartan, and you have until Sunday at basically midnight to finish this Unit 7 test. So you have some time, but we want to get this test done sometime this week after Wednesday. And then again, we do not have school on Friday, so there's no assignment or anything for Friday. So that I just want to paint the week and let you know where we're headed. We've learned everything we knew that we're going to learn. This week is just a kind of review. So please let me know if you have any questions regarding that. And again, I will update your grades here tonight as we go through, and you can kind of check to see how you did on quizzes and tests. And if you didn't do well on a quiz, remember you can do corrections on a separate sheet of paper and just send those in to me. And you can earn up to 100% back on anything you got wrong. All right, so let's go over this part. I'm going to set Nellie down here quick. Okay, sorry about all this. It's definitely a unique day. All right, let's look at how do we do these slope fields? Now, one of the things that I had mentioned in the video was you could make a chart here and just do all the slopes, or look at the patterns, right? If I look at this pattern, this slope formula says x times y minus 1 divided by 4. That's the slope. Well, what if x is 0? If x is 0, I don't care what any of this else is. It's going to be 0 divided by 4, which is 0. So that means whenever x is 0, the slopes will be 0. So I'm going to put a 0 slope at each one of those pieces. All right? Now, we have other patterns. What else is true? What about when y is equal to 1? Right? If y is equal to 1, 1 minus 1 is 0. So that will make the entire numerator 0, which means whenever y is equal to 1, I also have 0 slopes. So I was able to basically reduce a ton of these points down to really I just have to find 6 different slopes now. So hopefully those are patterns that you have discovered or you are going to discover as we review more and more today. So now, how do I find the slopes for the other points? Well, you don't have to show work for these, but let's look at this point right here. Over 0, over 1 up 0. So if x is 1 and y is 0, you get 1 times -1, which is -1/4. So then you want to do a slope that's about up, well, actually -1/4. So I want to basically go down 1 over 4, which would be a slope that looks roughly like that. And again, your slopes are not perfect here. They're just estimates. You want to get as close as possible. All right. So now we'll do the one when x is 1, and I'll go up 2. Well, notice if x is 1, for this whole value, that doesn't change it. So it's really just thinking, what does the y value do? If I plug in 2 here, 2 minus 1 is 1. This is a positive 1/4. So I want to go up 1 over 4 roughly, and I'm going to draw a line that looks like that. So it's about a 1/4 slope. But notice it is positive. Okay, and then I'm going to go over 1 up 1, 2, 3. So what if I put a 1 here and a 3 here? I get 2 over 4, which is 1/2. So then this will be up 1 over 2 roughly. It should be steeper than this slope, but not by much. And they're not going to really grade these. I mean, they're not going to get a ruler out and see that you perfectly did 1/2. What they do is they grade it with a blind eye roughly, meaning they kind of blur their eye. And if it looks like it's a little bit steeper, then you're good. Okay. So now what about when x is -1, right? Here's when x is -1. Well, that's just going to make all of these the opposite sign, right? Because if this was at the spot over 1 up 0, then I get -1 times -1, which is a positive 1/4, which is the opposite of this sign. So I'm just going to make this a 1/4 slope versus a -1/4. And the same thing is over here. If this was a 1/4 positive slope, this would be reflected down and be negative. And this one was a positive 1/2, so this should be a -1/2. So there's patterns that you can use, and that's what we're going to really focus on today, is identifying these patterns to help get your slope field. So there's part 1. Part 2, or B, says let y equal f of x be the particular solution to the given differential equation with the initial condition 1, 3. Write the equation of the tangent line. So right there, I hope you're thinking, I need a point, and I need a slope. Well, they give me the point, and I have to find the slope. Which, by the way, you technically already found the slope right here. Over 1, up 1, 2, 3. We knew that this slope right here sorry, my pen is acting a little odd here. So we knew that this slope was 1/2. Okay, right here. We calculated it. So what is part B? If I want to find the slope part, that was the slope at this line right here, which is dy dx, 1/2, or just plug in 3 here and 1 here. And when you do that, you'll get a 2 over 4 or a 1/2. So that's where the 1/2 came from. And then we know the point itself was x is 1, so x1, y1. And technically you could stop there. That's the equation of the tangent line. However, they say then use that to approximate 1.4. So what I'm going to do is actually simplify this and distribute. And then if I add 3 over here, this will give me 2.5. So here's my equation of the tangent line. And keep in mind, they tell me that y equals f of x. So here, because I said y equals, that's the same thing as f of x. And then we're going to use this to find the value at 1.4. So I'm just going to plug in 1.4 to finish part B. So then half of 1.4 is 0.7. And 0.7 plus 0.5 is 3.2. Okay. So that's part B. And then part C is the actual separation of the variables and doing the antiderivative like we've done before. So now we say find the particular solution. So what we're going to do here is we're going to separate the variables. And this is just a little bit tricky. Notice y minus 1 is the only part that needs to move over. The x divided by 4 can stay. So I'm going to divide by a y minus 1. And then move the dx over as well to get the separation of variables. Okay. Then if you want, over on this side, you can do a u substitution. You can let u, oh, hold on. This is definitely a new challenge today. We're going to let the u value equal y minus 1. And when we do that, we get the derivative of u. So we're doing a u substitution here. And the nice thing is when you take the derivative of both sides, you just get dy. So all that does is turn this left integral into 1 over u du. And then we can quickly take the antiderivative of that by getting the natural log of u. All right, so then we know what u is. U is y minus 1. So that's how we would do the antiderivative of the left side. If you recognize that y minus 1 is just linear, and when you do u substitution, you're just going to basically get right here. You can skip all of this work and go right from here to here. You don't have to show all this work if you can do that in your head. All right, now this one, remember that 1/4 is a constant. So now I'm just going to find the antiderivative of x, which is x squared. If I put a 2 up top, I have to put a 1/2 out front and a plus c. So then I get 1/8 x squared plus c. And then I guess I would write that down here because that's where we plug u back in. All right, so now we're at the point where I have the value where c first appears, right? Which means we're then going to use the initial condition to figure out what actually is the c value. So I'm going to plug in 3 for y and 1 for x. Do that in a separate color here. All right, so then we'll simplify. We get the natural log of the absolute value of 2 equals 1/8 times 1 is 1/8 plus c. And then I just got to solve. I'm going to basically use the absolute value of 2 just to call that 2, so I don't need the absolute value bars anymore for that part. And then I'll subtract the 1/8. So there's my c value. And that c goes right back in to the spot where c first appeared once it was part of the equation with y. So now we get, too big. Now we get to the point where we got to find the particular solution and make it equal to y. So I'm going to plug in whatever c was, which is this whole big piece. And then you do have to solve for y. Right? So now I got to get y by itself, which means I'm going to use property from pre-calc. To get rid of the natural log, I'm going to raise both sides to the power of e. So I'm left with the absolute value of y minus 1 equals e to the 1/8 x squared plus ln 2 minus 1/8. Now, you could try to break this down because technically the e and the ln of 2 would reduce out and you would get a constant of 2 out here. Or you could leave it. You actually don't get any more extra points for fixing this. But what I would do then is see this minus 1, it's going to have to move over. And you can put it out in front, you can put it at the end. I'm going to just put the plus 1 at the end. Now the question then is, where did the absolute value bar go? Why did I leave that out? Well, the reason why is, think of this, if I plug 1 in, e to any power will be positive. Your answer actually ends up being 2, and 2 plus 1 is a positive 3. So since this is a positive, this answer right here is going to be positive, which means I'll leave it. Okay. Now, this is one form of the answer. Algebraically, it could be written differently, but I don't think it's really worth doing that. Okay, so let me show you how the AP test would grade this, just so you guys can see how they wrote their answers and how they would assign the points. Okay, so here's how they would grade a problem like this, which, by the way, this problem is a really good review for your test. You're going to be asked to do all parts, A, B, and C, for sure. And you might even have a problem in this very similar structure. So, part A was worth 2 points. You got 1 point if you correctly identified all the spots that had the 0 slopes. So that's what we talked about, those yellow spots there. Right? And then you got 1 other point if you got the other ones correct. So that's how they grade part A. How would they grade part B? Well, part B was you got 1 point, it's 2 points total. You got 1 point if you wrote the equation of the tangent line. Some form of this. Now, algebraically, it could be distributed. If it's an algebraic equivalent to this, they would give you that 1 point. And then you got another point if your approximation, so you used this value and plugged in 1.4, and you got 3.2. So you get 2 points for part B. And then look at the amount of points awarded for part C. 5 points for that free response question. So the very first point, now this is really important, is the separation of variables. So remember how we took this y minus 1 and we brought it over? That's the importance of showing the setup. You get 1 point for just writing this. Even if you don't know how to solve it after that, everybody should be able to get 1 point. I want to scroll down, there's a little caveat down here. If you do not separate the variables, you automatically get 0 points. Meaning any work that you do after that, if you did not correctly move the y minus 1 over, if you left x and y on the same side, they wouldn't, I don't even think they would look at your work because it's not worth grading after that. So that's the part of separating the x's and y's that we talked about. Okay? And then you got 2 points for the antiderivative. So basically, did you get the antiderivative of the left side correct? That would be worth 1 point. Did you get the antiderivative for the right side correct? Okay? And then don't forget the plus c. Sometimes they give you 1 point just for putting plus c in. And then another point was constant of integration and uses the initial condition. So basically they're saying, did you put the plus c? And then did you use the points to find the c value? So if you found c correctly, you basically got that 1 point. Right? And then the last point is, did you solve correctly for y? So once you plug in this c back in like we did right here, did you solve for y? And did you get an algebraic equivalent? You can see that our answer was not identical to this one in terms of the way it looks, but algebraically it's equivalent. So the answer we had would have earned that 1 point as well. And my advice is get y by itself and don't do anything super crazy algebraic wise. Stop simplifying when you don't get any extra points for simplifying further. Great question. This would totally be a no calculator question on the AP test because we didn't need our calculator for any of this. Even this part right here, we could do that in our head. So that's really our first full AP question that we've done together right here. And by the way, I will post these so you can kind of check your answers. My goal here is to go over a couple of more pieces on slope fields, just so you guys understand the patterns that we're looking for, okay? Now, don't write this one down, and actually, I didn't have time to set up the Zoom poll, so I'm just gonna let you guys think about this problem as we go over it. So let's take a look at what this problem is actually asking us. This would be a no calculator multiple choice question, and it gives us a slope field. Now, right away, before we even look at the question, let's look at what we know. All of those are zero slopes. I will never be able to cross a zero slope line, so that means that this is a horizontal asymptote. So we got a horizontal asymptote somewhere up here. Doesn't really matter where. Now, I'm not positive right now, just from looking at the graph, if I have zero slopes here or if they're undefined, because there's no markings that clearly tell it. So I'm not sure what's going on right here. But I do notice that there are more zero slopes down here. So there's my horizontal asymptotes, which means I cannot cross this line or this line. All right, now let's read the question and just kind of see what's going on. It says, shown above is a slope field for the differential equation. So here's the equation. If y equals g of x is the solution to a differential equation, we have to say, well, g of x has the point at -2, -1. So if I went over -2, down 1, that might put me somewhere right here, roughly. And again, we don't have exact values, so I'm kind of guessing on this point. However, it says, then, what is the limit as g approaches infinity? All right, how do we approach that? Well, g is the answer to this solution. Right? Y is equal to G. So if I solved this, which by the way, we can't solve this, because this is one of those ones that's really difficult for us to actually find the antiderivative and work through. However, a slope field can help us out. So let's look at this answer. I'm going to assume, well, actually, I don't have to assume. Let's look at this. What happens when y is equal to 0? Right? If I plug in 0 here and 0 here, I end up with a 0 slope. So I actually know there are another horizontal asymptote right here. And I know that because when I plugged in y equals 0, I actually ended up with the answer of 0. So now, what if I drew a solution curve from the given point? Well, it's going to follow the slopes of this curve, so it's going to basically go down, and then it's never going to hit 0, so it's just going to keep on going. And then this one will go up, and then it's going to get closer to 0, and it's never going to cross. So this blue graph is the graph of g of x. And the limit says what happens when x goes to infinity. Well, as I go far, 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 far to the right, this graph is getting closer and closer to the value of 0. So that's understanding what the 0 slopes mean and understanding how to read the equation. And then they threw in limit notation. So kind of a good review overall. Okay, this one you might want to write down just as notes today. If you don't want to write it down, it will be posted in Schoology, so you can always go back and look at it. All right, so let's take a look here at what do we know about analyzing slope fields. Well, for each differential equation, determine when the slope will be positive, negative, undefined, or 0. Well, let's think about what that actually means. First off, when I see the word slope, I think dy dx, right? The slope field is the slopes or the graph of all the little tangent lines at every point. Now, what has to be true if we have a positive slope? Well, dy dx has to be greater than 0. Right? Anytime you have a positive slope, your slopes are positive. Okay, what has to be true if it's negative? Dy dx is less than 0. Those are the ones that aren't super. I mean, you probably don't even have to write those down, but this one is important. What is true when you have an undefined slope? Well, undefined slopes have vertical tangent lines. Right? So that's important to note. And this is really important. What do you know about the slope? Well, if it's a vertical tangent, then dy dx does not exist. It's a vertical line, therefore the slope can't exist. Well, what does that mean? If you have a number, any number divided by 0, then you're going to have an undefined slope. Now, what about a 0 slope? As we just saw in the last example, that's a horizontal tangent line. Right? So anytime you have a horizontal line going straight across left and right, that's a 0 slope. So what does that mean? That means that dy dx is equal to 0, which means we have 0 divided by any kind of number. So how are we going to use this information? Right? Because we don't want to, and we don't need to, draw a slope field to determine when slopes are going to be positive, negative, undefined, or 0. Because we can look at the patterns within the problem and determine if it's positive, negative, undefined, or 0. from this information here. Okay, so let's look at this first example and just determine, without even looking at a graph, when are we going to have positive, negative, or undefined, or zero slopes? So what we're going to do is we're going to answer this generally because we want to figure out all the areas at which this will be positive. So what's my equation? My equation is x times y squared. Let's think about this part right here. If a number is squared, y squared, that means that the y part, no matter what it is always positive. Right? So for any time I go down, like -2, the y value would then be squared and turn into a positive. So that means that the value, the sign of the slopes, is controlled by the x's. So what does that mean? When x is greater than 0, my values are going to be positive, right? When I plug in positive numbers, a positive times a positive will be a positive slope. So how would I answer this? I would just say anytime x is 0 will result in positive slopes. Well, likewise, anytime x is negative, I will get 0 slopes as well. So nothing really crazy for those. But what about the undefined piece? Now, remember, what is undefined? A vertical tangent, which means I would have to divide by 0. This is a product. It's the multiplication. I'm not dividing. So this part is not applicable, or it will never happen because we're not dividing. Okay? And then the last one, what about the 0? When do I have 0 slopes? Well, what's going to make this equal to 0? If x is 0 or y is 0, I will get a 0 slope. So how would I answer that? dy dx must be equal to 0 whenever x is equal to 0 or y is equal to 0. Okay. Now, I know this isn't super easy for us to just get it on one example. What I did then was I provided the slope field. You do not have to draw this. I just wanted to show you what I was talking about when we did each part. So let's think about this. What do you know when x is positive? Well, when x is positive, that means I'm moving to the right. Look at all the slopes to the right of 0. All of these slopes right here are all positive. And that would be true for any points that I graph. If I graph more over here, all of these would be positive. If I graph down, or anytime x is greater than 0, we know the slopes are going to be equal to 0. Okay? Now, actually, I should add one extra point because this technically is not perfect. We're missing one thing, right? Because what about here, x is positive. So we do actually have to add one thing. Y cannot be equal to 0. Because if y is equal to 0, that's going to overrule it and make it a 0 slope. Okay. Well, let's look at this one. What about when x is negative? Look at all the slopes to the left of here. So if I went over -1, all of these slopes would be negative. Same thing here. Bunch of negative slopes. And I do have to add that extra little caveat in there that y cannot equal 0. If y is 0, that gives me 0 slopes. Okay, and then the last one, we didn't have any undefined slopes. So that means when do we have 0 slopes? Whenever x is equal to 0, which is right here. Or whenever y is equal to 0, which is right here. So notice those patterns that we talked about. That's the important part, is we didn't need a graph to answer these questions. We noticed it in the equation itself. So I want you guys let's do this. I want you to try this one. See if you can look at the patterns and think about when is this slope going to be negative, positive, undefined, or zero for which values. And then we'll confirm that with the graph. All right, let's take a look at this and see how this one works. So this one's a little more unique because we have y is negative and x is kind of regular, or I should say y is opposite of what it says. So let's look at how do I know if I have positive slopes? Well, what I need is think about what if x is positive, okay? If x is a positive number and y is positive, then this will turn it the opposite sign. So anytime x and y are opposite signs, you're going to actually have a negative. If I'm sorry, you'll have a positive because what I want is I want this y to be a negative, right? If y is negative, then a negative and a negative will be a positive. So when do I have positive slopes? When x is positive and y is negative. Right? Now we also should throw in there that y cannot equal 0. Actually, x or y cannot equal 0. Let me put that up top. Right? Because if x was 0, that changes this completely. If y was equal to 0, that's an answer to the other problem. So now, all right, so let's look at negative. What is going to make this a negative value? Well, if x and y are the same signs, right? If y was positive and x was positive, then you'll get a negative answer. Or what if y is negative, right? If y is negative and x is negative, then you're going to get a positive answer as well, or a negative answer, because a negative and a negative will be a positive over a negative, which is still negative. So when is this negative? Anytime x and y are opposite signs. That will always produce a negative answer. Okay. What about undefined? This is usually the kind of question they ask, but when will this be an undefined slope? Anytime you divide by 0. Well, what's going to make this 0? Whenever x is equal to 0. And then when is this going to be a 0 slope? Anytime the top part is 0. So whenever y is equal to 0, oh, don't play with that. But we also have to put in here x cannot equal 0, because if x was 0, that would be an undefined slope. All right? Now, I'm thinking, did I answer everything for the positive question correctly? So if x is positive, you could actually have, if x was negative and y was negative, no. This one, actually, I think I answered this wrong. This one is any time you have x and y are opposite signs. It's the same answer. Right? Opposite. No, same signs. Sorry. Sorry, I was a little distracted. Anytime x and y are the same signs, you will get a positive slope. So x and y are the same signs, right? Because if they're the same signs, this one will turn the opposite, and then you'll get one positive and one negative, either on top or on bottom, but either way, it will result in the same value. All right, let's take a look at the next one. This one's an interesting one. Oh, here's my slopes. Double check that. So when do I have positive slopes? Well, positive slopes, when are they increasing? That's anything in this region and anything in this region. So x and that goes around. I did. Today is definitely not my day. Whenever x and y are the opposite signs, so here x was negative and y was positive, and when x is positive and y is negative, those are when you'll produce positive slopes. When x and y are the same signs, that's the negative. I made that way harder than it needed to be. So here you can see all of these. I'll cover it all because it's every point. It's not just the points that are labeled, it's all the points. And then these are negative slopes as well. Okay. And then when do we have zero slopes? Well, zero slopes are whenever x and y are equal to, or whenever y is equal to 0. So whenever y is 0, that's all of these. But notice, I didn't cover the spot right here at x equals 0. And the reason why is because whenever x is 0, that's undefined. And for undefined slopes, sometimes they draw them, sometimes they don't. Either one is acceptable. You could draw a vertical line or you could leave it blank. All right, and then let's look at this last one here. So we'll do this one together because it's a little bit tricky. So when do I have positive slopes? Now this is rather important for us to be able to analyze. Notice, it does not matter what x is. X could be positive or negative because I'm going to square it. Whenever I square it, this value will always be positive, which means the sign values are going to be determined by the y. So there's a couple ways that you could do this. When will this be greater than 0? Anytime y is greater than -3. If I plug in -3 here, -3 plus 3 is 0. So any number that's greater than -3, like -2, that would produce a positive answer. So we're going to say here, when y is greater than -3, but we also have to add that little caveat here because we have one small problem. When x is 1, 1 minus 1 is 0, and that would affect this. So we have to say x cannot equal positive 1. And then when is it going to be negative? Well, if it's less than -3, those are going to be all negative values that come out of the y portion, but we still have to say that x cannot equal 1 because that would produce a 0 slope. Well, then we just answered our own question here. The 0 slope, whenever y is equal to -3, we'll get a 0, so that'll produce a 0 slope, or whenever x is equal to positive 1, then we'll get a 0 slope. Okay, and then the last part, when is it undefined? Well, I will never divide by 0 because this is a product, it's not a division. So that will never happen. So the important thing is to think about the sign value. That always makes things positive, which really helps. Now I have my slope fields that I can just kind of generally check. And here I produced a lot more of them just so you guys can see. I'm going to actually highlight the zero slopes first because that I think is one of the easier things to do. Whenever y is equal to -3, so if I go down 3, you can see here are all the zero slopes. And whenever x is equal to 1, so if I go over 1, here are all the zero slopes. And then when is y positive? Anytime the slope is positive, anytime y is greater than -3. Well, look at all the values from here up are all positive. Oh man, I didn't realize at the time. So I think we got through what we need to get through here. You guys can check all of these would be negative. Here's the goal for today. Do the optional worksheet if you'd like. Get all your homework in, and then tests will be available. It should say Wednesday afternoon for you guys. All right. Thank you for your patience. Today was not an ideal day. I will not be available for office hours today, but I will be on Wednesday. So you can stop in and get some help if you need it. Adios. Have a good day. Thank you again for your